Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now let's just start the session number 34, which is based on a force multiplications. The primary function of a hydraulic system is to transmit force through a confined fluid from one location to another location. Another useful function of fluid power is its capability of multiplying force. The multiplication of force by a hydraulic system is made possible by using a piston that is larger than the piston on which the force is applied. The figure shows the concept of force multiplication. Pressure of the fluid due to force F1 applied on the plunger of diameter D1 will be P is equal to F1 by pi by D1 square by 4. That is nothing but force is equal to pressure into area. Using that expression, this was written. Similarly, force extended on the ram of diameter D2 by the fluid due to pressure P, which could be written as F2 is equal to P into pi by 4 D2 square, or it can also be written as P is equal to F2 by pi by 4 D2 square. Now, equating these two equations, we can get the form like F2 by pi by 4 D2 square is equal to F1 by pi by 1 D1 square by 4. Upon cancelling pi by 4, we will get F2 is equal to, in terms of F1 into D2 by D1 whole square. That is, larger the ratio, larger will be the force multiplication and will be the square of the ratio. Force multiplication is a function of a square of the ratio of the diameter of the larger piston to diameter of a smaller piston, which will be called as a plunger in the figure. But this is at the cost of displacement. For large displacement of the plunger, there will be a small displacement of the ram which is going to take place. Now for which the condition is work done by the plunger must be equal to work done by ram. So that is nothing but force applied in the distance x1 must be equal to force obtained for a ram at 2 for the distance x2, that is, which can be written as x1 is equal to f1 by f2, or in terms of x2 will be equal to f1 by f1 into d2 by d1 into x1, and finally f1 gets cancels, and final remaining equation will be x2 is equal to d2 by d1 whole square multiplied by x1. That is nothing but the displacement is inverse of the force multiplication. Now let us understand the next concept, which is called as speed control of hydraulic cylinders. The speed of an actuator can be varied by varying the flow rate. Flow rate can be controlled by flow controlling valves. Various types of flow control valve or throttle valve are available and may be used. Flow control valve may be either ordinary type or compensated type, and the type of flow control valve used depends on the accuracy of control necessary. Variable displacement pump can also be used for control of speed of a hydraulic cylinder, but is suitable for controlling a single load. When many varying loads are to be controlled, then individual speed control is adopted, and the simplest being use of throttle valve, for which we will understand more clearly in three techniques, that is called as meter in, meter out, and bypass control. The simplest method of controlling the speed of an actuator by varying the flow by using the control valve or a throttle valve. And the throttle valve, as I have mentioned, it can be discussed in, meter out and bypass circuit. We will discuss one by one. In meter in circuit, the flow control valve is placed in the pressure line as shown in the figure. In this, only the rate of flow to the actuator is controlled. Pump delivery is excess of metered amount is diverted to tank through the pressure relief valve. Then what are the advantages of this one? A finer speed control is possible, also suits for high pressure system, and in addition to it, the cylinder is subjected to pressure from one end and the pressure corresponds to actual load applied. And then the relatively low level of friction at the piston guarantees a longer service life and uniform shift even at low speeds. But it is having some disadvantages like pressure drops across due to throttle, and hence pressure of the fluid fed into the actuator will be a less than desired. Also cannot be used for hydromotor and somewhat inefficient since excess flow goes back to the tank, and it also can only be used for opposing loads and then cannot prevent the load from running away, and at last heat generated due to the throttling is fed to the actuator or the disadvantages of meter in circuit. In meter out circuit, the throttle valve is placed in return line to control flow of fluid coming out or returning from the actuator. The speed of the cylinder controlled by regulating the size of the opening of a throttle valve. If the flow control valve were closed completely, no oil can flow exhaust the cylinder, thus stopping the movement of the cylinder completely. And the figure at the middle shows the meter out hydraulic circuits. What are the advantages will follow one by one. No loss of pressure of oil at the head end of the cylinder. The actuator movement is more stable, suitable for controlling the speed of both cylinders and motors. Heat generated during throttling goes to the reservoir, provide positive speed control of cylinders. Pump works against the maximum pressure, most popular circuit due to its positive speed control capacity and stability. Then coming to disadvantages, even at no load, the cylinder is subjected to maximum pressure. The right hand side of the cylinder is subjected to a counter pressure which increases the area ratio capital A by A. The higher level of friction, less uniform shift characteristics and stick slip effect is going to take place. If the flow control valve is installed after the direction control valve, the leakage in the direction control valve will have the effect on the accuracy. Then coming to the next type of speed control of hydraulic cylinder is called as bypass control circuit. In bypass control, the pump delivery is passed on to the tank through a throttle valve at the system pressure. Pump pressure varies with the load instead of being continuously fixed at the relief valve setting. The figure shows the bypass circuit valves, which is also called as bleed off circuit. Then what are the advantages of this one? Improvement in efficiency. Heat generated due to throttle is fed to the tank. And coming to the disadvantages part, positive speed control is not possible, does not suit for accumulator circuit. Fluctuation of flow rate in pump affects the speed of the actuator. Pump works again as the load, can be used for fixed displacement pump and motor. The motor continues to rotate even when pump delivery is cut off from the fluid motor. Not efficient with variable displacement pump. These are the disadvantages. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan.